As a student here, I was actually in this classroom, the first class ever held at Portland State University in this building. Little known trivia. So today we're here to discuss the School of Business Administration expansion and renovation project. Essentially what happened, this is kind of a decades-long process. That's not a pretty sight. That was the current state of the School of Education and the School of Business Administration in what was built in two phases called the Professional Schools Building, specifically for business and teaching. Over the years, the architecture hasn't been quite eye-appealing anymore, and there's been several, and the building systems are quite old, so there needed to be a lot of work done in the building. So the School of Business Administration, their ratings as far as a university and school have been going up and up and up and up, and the building's been going down and down and down. So the School of Business Administration launched a campaign both with the state, trying to get funding from the state, and also seeking private donations. This has been going on for about 10 years. So about 4 or 5 years ago, the state finally coughed up $40 million. Yee-hoo. And then we got some private donations in about $20 million. Now this funding didn't come in all at once. We only had about $10 million in hand when Skanska and what's going to be the architect and engineering firm were hired. But it was enough to get going because the funding would be coming in as we would be spending it. We began the process, Portland State, we're the owner. We sent out what's known as a request for proposal. A request for proposal basically asks firms, says, hey, how are you qualified to build this for us? They tell us, we rate them and score them and have meetings, and then we hire them. It was a very competitive process. 10 firms submitted proposals. SRG Partnership Incorporated with Banish Architecten were chosen. Now this was kind of a, SRG is local, so they know all local codes and this and that. Banish Architecten is kind of famous for doing weird, funky things in close-in environments with light in the building and all this, and so it kind of looked like a good fit. Now, if you look at the date there, 1/8/14, that's the date we signed, we activated their contract. And I'm going to point that out in just a minute, why that's important. So the A&E team, the SRG put together, they called in landscape designers, structural designers, mechanical, electrical, climate consulting, because we're going for a certain certification, lighting, lead advisors, all kinds of things. Now as the owner, we're going to build a building. We want certain engineering also done on our side. Not only does Skanska and SRG have cost estimating, we hire our own cost estimator to double check, to make sure everybody's on the same page. We hired hazardous material because there's asbestos and lead paint in the building. That needs to be cleaned before it can be constructed. We also hire a special inspector. Now, Jared, as the structural engineer, is going to call for special inspections. The city of Portland is going to require special inspections. I'm the owner. I want to make sure it's built right, so I hire the special inspector. We also had geotechnical observations done. The site had to be watched and prepared for Jared to set the building on. He had to know the soil types. Also, because we've got this nice little atrium going in, we wanted to make sure that it would be waterproof. And then there's this little thing called 1% for art. Every major construction process in the city of Portland, you must donate 1% of the funding to art, and it must be public. So we got to pay for that. So we hire the answers. So SRG, Banish were already hired. We sent out another RFP in conjunction just a couple months after. Now, if you look at the date, 3/20/14. That's a month and a half after we signed our contract with the designers. Now we're bringing in the contract. CMGC, Construction Management General Contractor. Skanska was directly involved in the design process both for budgeting reasons, for constructability. This also gave us the ability to start construction before the full design was literally done. And I know that because I get RFIs across my desk every day. Again, very competitive. Same thing. We interviewed, we dug down deep, who's going to be on their team, that kind of thing. Skanska is ultimately responsible for delivering the final design, whatever it turns out to be, to me, the Portland State University. They're responsible for closing out all permits, obtaining the certificate of occupancy. Remember those two words, certificate of occupancy. And then give me the drawing so I have a record of it in the future. We wanted, as an owner, and the city of Portland's moving this way, we wanted a multi-use building. So here's a rendering of what's actually going to be built on 6th Avenue. 6th Avenue's right here, the Max Line's right here. And today you're going to see we're re-fencing this off because we're going to start the demo on this side of the building. The east side has been mostly finished, but it's now occupied. We could not empty the building. We had to hold people in half the building at a time. So we just moved them over to the renovated side here, and now we're going to tear this part down. Groundbreaking, but we had to do some things first. Remember that 1% for art? Whenever you have 1% for art, it becomes registered with the city. It can't go away. You have to do something. You can't just throw it out. So I got to design the footings for where we moved this to the other side of campus. That was kind of cool. But that had to happen first. In fact, the demo on this happened the day that Skanska started their demo on this. The other thing that had to happen is we're centrally located on the campus. We've got utilities running across sky bridges, underground, power, chilled water coming across campus from other, you heard I was on a $17 million campus loop project. Well, that's chilled water coming into the ASRC over here, feeding this building, feeding my office building. All of this had to be rerouted prior to construction, well, as part of the construction process, but before we could start on the building and renovation.
By the way, that took us 4 months just to clear that site with all those utilities.
It was kind of a monumental undertaking. In fact, before the project started, I told my boss, Mark Fuji, who's the project manager on this, I said, I don't want to be the design team on this because there's so much there. And he said, yeah, that's what they're like, I'll figure it out. Well, it took us 4 to 6 months just to figure out how to get this stuff rerouted. Because it's so integrated into the campus.
So, on that note, this project, really every project, always starts with that RFP process, but in that RFP process, we don't really know what the scope is. Yes, we know it's going to be 42,000 square feet and they have some money to spend, but ultimately, we didn't know how much renovation was going to happen to the existing facility. We really didn't know how much reroute of those utilities that Charles just mentioned were going to need to happen, and we didn't have any idea about how big the atrium was going to be, or even the new addition was going to be, and where it was going to be located, what it was going to be built out of. So when we, back in, I guess, January of 2014, I didn't know that, couldn't remember. In January of 2014, we sort of started with a rough idea about what we were going to need to do. And then we started meeting with SRG and Banish and exploring options, ideas. We knew that there was going to be a renovation, and I think the one piece that we knew most about the existing building was that we were going to reskin it, reclad the entire thing. But we didn't know what we were going to clad it out of. So we had lots of meetings up front to really discover what the building was. So we needed original drawings, and this project is actually different than most that we work on where we have existing buildings, in that we had really great data for the original building. So yes, thank you, Charles. So we knew a lot about the buildings going in, and we could answer a bunch of questions up front. What was possible with that recladding? Where could we put additions onto the existing structure? Where could we put new openings? What was possible, right? Here you see an image sort of halfway through demolition of, what is this? This is level 2, actually. This is level 3, 4, 5, and 6 up here, and so we're kind of halfway through the demolition. The original building is cast-in-place concrete, has a big shear wall core right down the center going all the way north to south through the building. As Charles mentioned, this building was built in 2 phases, 1981 here and 1989 over here, and they actually designed this original construction for the future expansion. So they knew that they were going to build a second building. They are tied together. They are not isolated. So it is one big building. It's all post-tension concrete slab construction, and it's essentially flat plate construction. There's no beams or girders or joists or anything in the building. And that is a significant complexity to any kind of renovation. Post-tension of any kind is under a great deal of force. Once you leave the project, you leave those tendons at about 27,000 pounds, and there's lots of them in every slab. So anytime we go about modifying or renovating or adding to that existing slab system, we have to take that into consideration. David will talk a little bit about this in terms of the constructability piece, but there's lots of scanning and knowledge that needs to be gained about where those tendons are in that structure so that we can manipulate that structure.
And I put a little E in parentheses on top there. You'll see that in your drawings in the future, and you'll use that in the drawings in the future. That means existing.
Is that the microphone?
This is the microphone.
Okay.
Yes, that's
Were
the
you
point.
done? I'm sorry. I don't want
I am done. You can flip. I may jump
so,
in.
so Jared and I are going to kind of tag team this.
David and I have been working together for a long time, so
Yep.
we pretty much finish each other's sentences.
Right.
It's one of those
I was
things
just
that
going to say that too. So when we were talking about what we were going to talk about, we kind of thought, well, let's discuss 3 topics of what you might want to hear. So the renovation was one topic, the pavilion, and then the atrium. So right now we're just going to focus on the renovation. So the whole part he started to lead into this is half of this building here is occupied. So people are occupying the space adjacent to all this work going on. So in order to pull that off, Skanska had to prepare and really plan for an occupancy concept. So this is kind of one piece of a very large document that says, hey, City of Portland, hey, PSU, here's how we plan on building your building while we're going to keep the space functioning. So we had to actually continue to move air, electricity's got to run through there, all the fire life safety systems have to continue to function. And that's actually probably a bigger feat than doing the construction itself. All this logistics was, we have all these temporary walls, all the mechanical systems had to be separated to continue to move air and maintain all of the life safety systems. So that's a big undertaking. So as an engineer, and I'm kind of thinking, it's like, well, what do you guys want to hear sitting in this audience, from a contractor standpoint? And I'm thinking, well, depending on, by show of hands, who's going to go, who has the ambition to be in construction? Anybody here? Construction? Okay, so there's some folks here, we're speaking to some of you guys, that we probably spent 3 or 4 months just figuring out how do we do this. So just because when you see those design documents, okay, yeah, that's, Jared says, hey, we got to do these openings, we got to add this steel, we got to add this concrete here. Well, that's probably part of the plan, but the bigger plan is how do you build around occupants? And more construction is this kind of construction. Most of my career in 16 years has been working in occupied facilities or around people. So you have to have that mindset. How do we keep people safe? And you're always thinking about, like, if my child, this is Jared's daughter, but if she were mine, or whoever, right? That you want to be able to, that person needs to be safe if they're just like right over here and we're working over here. How do you make sure, my daughter, my wife, my mother is going to be safe?
I think it's important to note that when you as an engineer produce a set of drawings and a design, the emphasis on that is it's a final, that's what's going to be finally constructed the day that whatever you're designing opens up. But there's a significant gap that happens there. David has to figure out how to go from where it is the day he gets the project to making and finally completing those drawings. And this is a major piece, both for David and PSU, but also the jurisdiction. Jurisdictions are now requiring this be developed and effectively permitted along with the drawings that we're preparing so that they understand how the occupants remain safe and the whole construction process.
I was going to say that.
Okay.
Good job.
We definitely rehearsed.
That's right.
Well, and safety is a big part of PSU too. We have our own safety officers that tour the site because ultimately we're sort of liable as the owner. So we also take heavy responsibility on safety.
Yep. But too, as a good contractor, we want to take care of the client so we get more work, right?
Yeah.
Just as these guys do.
Almost got that last job.
Yeah, almost. 0.6 away. Anyway, different story. You guys won't understand that. We're going to have to go into it.
Construction projects going on on campus right now.
Okay, so now we're going to move on to kind of technology. I had this kind of discussion of use of technology to avoid pitfalls. Okay, so Jared kind of talked a little bit about the pitfalls of a renovation. So here's some things that we do in order to look ahead. It's like, hey, what kind of problems are we going to have and how can we avoid that? Well, number one, this here is we have laser scanning equipment. You probably have seen this or heard of it, or, you know, that maybe been part of it. We scanned the underside and the tops of these decks so that we knew the undulations in them. The way that the final design looked, there was features that had to be accounted for that needed to know that information, like, hey, what's the deck doing? So down here you see this BIM image or building information model, the 3D model. This is the deck, here's some fire protection lines, here's this grill, and behind that, that purple are HVAC ducts. Well, we discovered that, let me just explain this real quick, back up a second. Red means it's concave, okay? Green, it's kind of right where it's supposed to be. We'll keep it simple like that. Well, in some of these areas, we had, these ducts were impacted by that, the belly of the deck. So what we had to do is we had to adjust all these in our model and push everything down so that it didn't interfere. And when you're pushing something down, the domino effect, of course, then there's other things too, like the top of this glass had to be adjusted. So that's a series of RFIs, a series of conversations. And each one of those impacts has a multitude of other ramifications. Additionally, across any one of these decks, between the atrium and this building, we expect that this floor is level. And in this case, there's a fire curtain that closes automatically in the event of a fire. So what happens is that curtain, as it slides all the way across 20, 30 feet, it has to seal on the bottom. Well, if it's concave or whatever, it's not going to seal. So that caused us to have to float out the entire floor, which PSU is not necessarily happy about spending another $180,000 on floor float.
I think we also found that level 2 there, you see that looks kind of like, if you see there too, we found that the ground had subsided underneath the slab also as part of that. And so it made sense at that point to just tear it up and re-pour it.
Yeah, right, yes. So there's all kinds of complexities and domino effect, and to be able to see the future is really important for a contractor to know what kind of problems are you going to have, because you are going to have problems building, particularly in a renovation. You want to add anything to this?
No.
Okay.
Yes, I do.
Here.
So the whole floor fill piece, this is where we get involved because adding floor fill to any slab is a great way to level out that slab, and obviously is needed in this scenario, but it also adds mass, weight to that slab that slab was potentially not designed for. And so then we have to, part of that RFI, request for information coming from the contractor is, hey, we're going to add a bunch of floor fill. We think it's about 1 inch or 2.5 inches, as the case may be in some places. What's that mean for the slab? Do we have a problem? Do we need to strengthen that slab? Remember, this is a post-tension concrete slab. Those are designed to be very efficient because you want to remove the most amount of reinforcing you can, and so they're not necessarily designed for, 4 to 30 pounds a square foot of additional dead load in addition to what it has to see in terms of occupied live load.
Okay, so next slide. Oh, go ahead, that's yours.
So the new, this is the Pavilion Edition. Again, my first statement was we didn't really know what this project was. This is the final design concept, but during early concept design, we call it schematic design, which is a kind of the initial design phase, we explored 13 different options for what the pavilion, what this addition could be. And then in those 13 different options, those were all just square footages, number of stories. We also explored different material types. There was lots of exploration about using heavy timber construction. We went through a whole design process of looking at cross-laminated timber for the floor slabs instead of concrete. Ultimately, that didn't win out as the best solution for the project, and so the pavilion structure is 5 stories, also reinforced concrete construction, also post-tension concrete slabs. There's very little regular grid system in the building, and so all of the slabs are different thicknesses. You'll see on the tour, you can see it right now, this big cantilever overhang. These columns come up and they support just this 4th floor level. We then transition to columns that are actually out here on the facade that supports a very large green roof assembly area. So, you know, everybody can go out there and have a picnic lunch if you want to, and when it's opened up. And we had to design this 4th floor slab to effectively transfer all of that load back into these columns. So this, you'll see some photographs later in the presentation where this was a significant engineering effort. I mean, months of engineering effort to figure that part out.
Okay, so building the pavilion, a couple bullets I want to talk about. First, the logistics of it, tower cranes. You guys see tower cranes all the time in Portland. What does that mean? BIM, building information modeling, clash detection before the bigger issues. Let's do it all on paper, or actually now all in 3D, you know, before we actually go do the work. And mitigating issues in advance, using technology again to inform future decisions. So it's really cool technology. And more, the industry, now we're working on goggles to, our company now issued us a grant to spend a bunch of money to figure out how do we employ goggles, 3D goggles, so we can walk people through spaces and figure things out, maybe even affect, you know, those systems in 3D, really cool stuff. So that's something Skanska is working on. Tower crane planning. So number 1, do you even use a tower crane? Maybe it doesn't make sense. Anybody think of maybe some criteria of why you not want to use a tower crane? I'm looking for an answer, maybe. Anybody?
Space goes too close.
Yeah, space. Yep. Yeah, well, even the tower crane itself does not have a lot of capacity. You'd think, oh, a tower crane, that's going to lift everything. No, it doesn't. At the tip of this tower crane, you can see the weight, 8,300 pounds. I'm not sure how much the biggest that rake beam we have. Do you remember how much that weighs? That's got to be.
Rake beam is.
It's really heavy.
Enormous.
It's enormous. But
it is more than you can pick at 50 feet. It's
yeah.
50,000 pounds, 70,000 pounds. It's
yeah.
enormous.
So even some of the stuff that, I mean, really the tower crane is more for like formwork, rebar, smaller things. We got to get all that material that this is, here you can see, this is the pavilion. Okay, that's the existing building you saw at the first slide. So this tower crane sits right here on Montgomery and Broadway, right up against the curb. You can obviously see it here too. That's the base of the tower crane. All this planning we did around this to figure out what, matter of fact, there's a lot of discussion even with Jared. We hired Jared to help us figure out how to employ, where to put the tower crane footing. The footing itself is 24 feet by 24 feet by 6 feet deep. Mm-hmm. So it's a huge mammoth, and it kind of sits underneath the street. So we had to dig that baby out of there. And, you know, also, does it really effectively help us to do things on the other side? So we actually have to supplement some of our hoisting with other cranes because this itself doesn't do everything for us. By the way, how much do you think at 1 month operating cost for tower crane? Any guesses? 50, pretty good guess. It's about $30,000 to operate a crane a month. So, okay, how much does a crane cost for a big, huge crane like one day? It could be $5,000 for a big crane for 1 day. So, all right, so what is it, you know, so you start to do the cost analysis of it too, and how much the capacity. So, by the way, it's like $300,000, $400,000 to erect and dismantle the crane too. So there's a tons. I mean, it's just before you even start working, you're spending, you know, $1 million.
And that footing is sacrificial.
And the footing is sacrificial. It stays there. So we had to actually bury, that's right. We had to bury that footing another 6 feet to allow other utilities to pass over the top of it. So you have to think about that. You have to know the design in order to plan where can we actually get away with putting this mammoth footing. So, okay, so now I'm going to move on to BIM. By the way, Jared, do you have anything to add to this? Or Charles, you guys have anything to add to this? Okay. So building information modeling, I'm sure you guys are very familiar with this. This is kind of like in your space now, and you're familiar with this is a cross section through the renovation, right down the middle of the building. You see this is the electrical gear. There's some mechanical systems that are coming from, you know, the exterior into the building. Everything that's colored is the stuff that we did as a contractor. So that's our responsibility to figure out, yeah, the design team says, hey, we need to do all this distribution and get all that in there, but now it's our turn to take all this over, and then we have technicians, BIM technicians, drafters, who do this, and they spend months. We spent 8 months probably in getting this right, tons of time. But the payoff is that when you get out in the field, they can take those same drawings and go to their shop and fabricate those and deliver them on a truck, and it goes up like Legos. That's pretty cool. Another picture of some of the modeling we do, and I'm sure a lot of you've already seen this. It's really a fun field to be in when you're, you know, doing this, and the architect can be in here, moving things around, and you know, all the collaboration that happens these days in the space is great. Okay, so mitigating issues. So moving on to a different topic. So this is a laser scan. Now we're essentially looking at the pavilion. This is the this is kind of hard to see, but give me a minute here. This is the pavilion. Okay. Third floor. This is the renovation. You saw this part of the building over here. That's the half that was being demolished. Okay, so we're kind of standing on the bridge, looking down. So what you see here, these green lines are the cables, the PT cables. The bluer lines you can see is a reinforcing concrete. You see some of these stub ups for columns. You see some blank space here for I'm sorry, I'm going backwards. That's the bridge. The pavilion's over here. I got you all backwards. Sorry. We're standing on top of that renovation building. So this is the atrium right here. In any case, let's move on to this is a close-up of one of the decks. So you can, what we use this for, because sometimes we might have to go back and core drill, and if you core drill through PT, that is not good. So we have to know where all that stuff is, and that laser scan is like taking a picture of it. Now we can dimension off of this too. Oops. You can see some of the studs. This is a steel plate across an opening. This is open space here. This is the deck. This is conduit here. That's buried in there. You got the cables, and you got blue lines that kind of represent the rebar. So
I think this is a really important feature that is not necessarily, I mean, this is fairly new for the laser scanning to occur during construction. And you have to realize that you get a bunch of stuff in the slab before you pour the concrete. You pour the concrete, and then there are anywhere from 10 to 15 subcontractors who come back and they need to hang a ceiling, or they need to hang a fire sprinkler line, or a whatever, and they need to drill something into that slab. When you don't know where your reinforcing is, it's Russian roulette. It's really what it is. And so this is extremely important, and I have to say that most of our higher ed and healthcare projects, we do not use post-tensioned construction. And we don't, because those are the facilities that get renovated and remodeled the most. I mean, I would imagine that Charles will call in 5 years and say, I need to do a renovation of this portion of whatever floor of the pavilion. What do I need to do? And at that point, we have to then go back to David's laser scans and say, okay, here's the implication. So this is a huge tool for us to be able to be successful for any kind of future renovation that happens.
okay, so here's some pictures going through building the shoring decks that we're going to pour concrete on. So this is the big, the huge cantilever that Jared was talking about. You can see all the steel. How thick is that? That's probably
That's like 30 inches thick.
30 inches thick right there, because you can kind of make out this tier where you have an upper deck in the classroom, and then down you have another kind of lower tier so the classroom faces this way.
Yep.
So we're getting that ready to pour.
So
If you look, you see this kind of the solid black lines going across. Those are your tendons. And both ways, he's got them, Jared's got them coming across the column strips, and just from your PT classes, you'll notice that.
I mentioned earlier how long we spent designing this portion of the project. We did so because this was not the original solution. The original solution, there was always a cantilever there, but the original solution utilized a more traditional beam that ran out over the columns and picked up the load from up above. But that beam was in conflict with a soffitting condition that SRG and Banish were really interested in preserving. And so then we thought about, well, we could add thickness to the bottom of the slab, which is a much, much easier thing to do in terms of the construction, right? But then that was in conflict with the tops of the windows and their elevations. And so then we finally got to this solution, which was to utilize a built-in tiered classroom, and we're utilizing that increase in the elevation for the seating, like you're sitting on right now, as part of the structure. So that's inefficient structurally, and so you see a lot of extra reinforcing, both post-tension and mild reinforcing, to make that work. And it's still working. They pulled out the high bay shoring, which is this stuff on the left, and the slabs haven't moved at all, which is the goal, right? We design our structures for capacity to begin with, but ultimately it's deflection due to gravity. Gravity's happening 100% of the time. Deflections are the things that lead to the biggest challenges for a building owner, and we're dealing with that. Again, back to the renovation, we're dealing with that right now. Those original slabs deflected a lot out at the tips. We had to pour a leveling compound on the slabs just because of their deflection. We're doing something different here so that we can control that deflection long term on these slabs, and we don't have to do leveling compound, which is good. More construction photos.
This is this one.
Yep, there you can see it. I have the clicker. So these lines that Charles was saying, these are our, actually this is our distributed direction of tendons. So for those who've taken post-tension design, you have, generally speaking, we run our tendons in a distributed direction and in a banded direction. It's kind of like joists and then a beam, or a girder, if you will. And here's our banded direction here. Honestly, in this slab, we could have gone either direction. It made more sense for us to try to keep this big cantilevered edge of the slab up in the air by utilizing equivalent series of tendons running along there to really lift that slab up. And you can see the significant amount of reinforcing that we have here. This is why having a CMGC is really, really helpful on a project that is this complex. We understood at some point, after we kind of redesigned this for the third or fourth time, we understood that this was going to be poured in two distinct pours. Working with their superintendent of concrete construction, they're going to pour this lower deck first all the way through, and they will have a whole bunch of reinforcing stubbed out and just sitting there ready for a secondary pour. This elevated portion was a secondary pour for them. We needed to add enough reinforcing in this between the two pores so that they could stress the tendons between those two pores and not pop that top secondary pour off. That would have been catastrophic. We'd all be singing the blues.
So, you know, something else too about just the construction methodology about getting concrete up here, because you think, oh, we'll just get some concrete trucks and pour it. Well, there's a lot of considerations too on kind of the slump and how much to get concrete to flow through. Sometimes you have a lot of rebar and you can't get it to flow and you can't get it to consolidate. So some of that too is we're asking Jared for maybe some design change or add mixers in order to get the concrete to a little bit more flowable. We have those vibrators that allow that to, to consolidate. But there's a lot also in how the concrete design mix. I'm sure you guys are aware who've had.
Then on my end of it, I've got my special inspector out there, Carlson Testing. They're pouring concrete. My special inspector is grabbing cylinders to test later. So, and then I get, and Skanska gets, the 7-day and 28-day average compressive strengths on these, on the concrete that goes in here. And Jared's often calling for 6,000 PSI concrete, and I'm getting numbers back like 8,000 and 9,000 PSI concrete.
That's better than 3,000.
It is good. One thing to note about this, this is a very special specification that we did for this slab and the 5th floor slab. I assume most people have seen concrete cylinders broken in your concrete classes and have looked at how they gain strength versus how they gain the modulus of elasticity. And those two values don't gain at the same rate, right? Modulus of elasticity takes considerably longer, which is a huge piece for deflection, right? Because modulus E is all about controlling the material property and keeping that deflection from being extreme. In this case, we took additional cylinders on site and made sure that Carlson was testing the modulus for the concrete, not just the strength, because we did not want that high bay shoring to be pulled out too early, which would induce a deflection in the slab if the modulus hadn't gotten to where we needed to the design capacity. In concrete construction, concrete creeps over time. And so a small amount of initial deflection can lead to a very large amount of deflection in the future. We wanted to control that small amount of deflection up front. We needed to do so by added cylinders. I think they took 40 cylinders between this slab and the 5th floor and to understand that modulus.
Okay, so we're going to move on here to keep it.
Oh, yeah, me. The atrium. Awesome. Well, this is the last piece of the project that's basically under construction right now. It's effectively a 90-foot tall skylight, is really what it is. Now, we're in charge of the structure that supports that skylight, but the skylight itself is what we call a delegated or deferred design to a subcontractor who has expertise. Basically going to build the skylight. And so early on, the subcontractor was selected. We had lots of meetings about how to make this work. You can see that it's both sloped and angled, so nothing makes sense ever at all. And in order to make this work and preserve a separation between the new building here and the existing building here for seismic purposes. We don't want the two buildings to talk to each other during an earthquake. We have a very large rake beam that runs the entire length of this skylight atrium, supported at the foundation here, and then at that concrete shear wall core up here. And it literally sits on a slide bearing, so that when this building shakes at a certain period and this building shakes at a divergent period, they don't pound into one another and they just slide along. The atrium is not heavy. That's the good news. We don't have a lot of mass we have to hold up in the air. We just have a very, very long distance to span a very big steel member. So this is effectively a customized steel bridge girder, for lack of a better term. And in between, at each of these floor levels, we are supporting that glazing. We're providing an opportunity for the skylight to sit and support there. So we're taking this from the pavilion in a series of very large tube steels back to this big rake beam here. Anything to add?
Nope. Okay, so the atrium construction, there's a couple points here. This is probably the most complex for us. Matter of fact, we think this probably has the most risk for us to get the job done on time. So we've spent a lot of, the last several months, like Jared said, getting this right, working between DMR is our skylight subcontractor, and Buffalo Welding is our steel subcontractor, and of course, Jared and our design team working a lot of hours to figure this out. Also making it waterproof. Of course, everything that Jared just said, we also have to make it waterproof. So Anybody figure that out? You have a job afterward, just come see me. Planning in BIM, again, this is all done in 3D. So just another perspective of this atrium. We'll go out and take it for those who are going to be there today on the job walk. I'll go kind of show you what this is beginning to look like. You can see that the materials that we have to interface with is, number one, we have the renovation, which is a metal panel structure. You've probably seen the new building and what that looks like. So we have also a seismic joint that we have to build and make sure that's sealed. On this side, we have a curtain wall or a glazing with then a wood soffit, then up against wood again. And then this is another wood soffit, then glass, wood, and then there's the roof up here with more sheet metal. Here's kind of a see-through of all of the elements that we have to bring all together.
Can you go back?
Yep.
So one thing I didn't mention is that there's also a bunch of stairs and bridges interconnecting the existing building and the pavilion. And those stairs and bridges are all anchored to the pavilion, so that's their home base, if you will, and they all sit on a series of steel members, a carriage of steel members on the existing building with, again, a bunch of slide bearings. So fairly complex. We need everything to slide nicely. We need it all to sit there and not deflect. You can see the large steel members that we're throwing in there to make sure that we can keep that bridge from being too bouncy as you go between floors.
Yeah, this is all the added steel he's talking about here.
We also, as an engineer, you have to pay attention to things like, hey, if it is too bouncy and you're 60 feet up above the base condition here and you're walking across a bridge, nobody's really going to want to walk across that bridge. So those are the things we have to really think, okay, it's not just about making the material work for capacity. It has to be comfortable and give people the confidence to actually utilize that pathway between the buildings.
So here's some of the construction. You can begin to see some of the, on the pavilion side, the steel members here and here. We'll go out and look at this. This is the other side where there's a curtain wall here, just, vertical curtain wall. Again, this kind of the point here in these next few slides is everything was happening in, we have two subcontractors basically have to come together and get their work to be like within a 1/16 of an inch. I mean, literally, we're building piano to get all this to work right. Everything has got to line up exactly because they're building all this in the shop and then bring it to the site. So it has to be dialed in, have to. Again, all these interfaces between the two subcontractors like this beam here. Again, all these systems are fabricated elsewhere. The steel, obviously all fabricated, it's got to come in here and sit at exactly and marry up with all of our concrete embeds. So that's why these models, I don't know how they did it before BIM. I have no idea how you do all this, on paper. That's just crazy. I don't get it. Oh, yeah, right. There's construction tolerances, but here, not on this job. Those are, we're demanded higher level of tolerances. All these concrete, this is a concrete wall in gray that's translucent here. So I wanted to show you the embeds here that have to marry up with these beams to carry the roof, and also this plate on top. These are embedded elements, then all have to marry up exactly because these all have compound angles, and then because this designer doesn't want to do anything straight, they like curves, they like angles, and that's just how they do their designs. Again, a lot more interfaces between all these elements. Here's one of the stairs between the renovation and the new pavilion. And that's it, because I wanted to try to get done here at 2:45. So anything else you want to add to the rest of that, or do we open up for questions?
The only thing that I would add is that projects, when I was going to college, you think, oh, I am doing my calculations perfectly. I'm carrying 14 significant figures. Everything, I am like the best engineer out there, which is great. But what you realize is that it doesn't really matter how good you are as an engineer if you can't integrate yourself with the entire project team, which takes communication, patience, and a whole lot of ability to see other people's perspective so that it's not just about the best engineering approach, it's about the best project approach. And
Amen.
that is how you do that.
Yeah.
So.
You don't build complex jobs with everybody working in silos. And
Right.
there's certain people we like to work with because we know, Jared being one of them, we know we can work together to figure out a collaborative solution. So, yeah, so I mean, we have a really good team. You know, all these guys are strong trade partners, strong design team members, great client to work with. So, you guys have any questions? We have, I guess, a few minutes.
Yes.
Hey, I'm curious, you were talking about how you would use the laser scanner, those post-tension floors and stuff. What did you do before you had that technology?
Hope?
Yes, and hope.
Yeah.
What typically happens is when I get construction projects in other buildings on campus, and the contractor wants to drill through somewhere, I'm going to say, not until you give me your scan report. I will
X-ray it.
Ground penetrating radar kind of thing. But yeah, won't let them. Contractors can't drill without giving me a note that they know there's nothing there.
It used to be that we used X-ray, and it was 50% accurate, maybe. I mean, yeah, people would X-ray and they'd still hit a tendon. The technology changes have really helped.
I remember actually taking X-ray paper underneath the deck and transferring that to the other side to make sure you're where you are, because that had to be perfect. So that's how we did it. I don't know what they did before that. Other questions? That's a good question, by the way.
Yeah, basically, in my time in construction, I used to be a carpenter. In the last 20 years or so, it's almost a different ballgame now. Safety is primary. There's no more have a beer on the job site.
As far as we know.
I think you know.
Right, yeah, we do know.
It's really a professional thing now.
Yeah, it's a good, whether you're a designer or you're a contractor, it's a fun field, and I think we all get a lot of satisfaction out when we seeing a building come out of the ground as complex as this and having your fingerprint on the skyline of Portland. Really cool. So whatever field you choose, you're going to get satisfaction out of it. Any questions at all?
Were there any seismic upgrades done to the existing building? I mean, I know you mentioned
That's a good question.
some seismic resiliency done with that.
Right. So we were approached early on by PSU to say, hey, we want to, if we can, include a seismic upgrade of the building. We did a preliminary study of the existing building and actually found the building itself has, while it has some deficiencies because it's built in the 80s, it is not so deficient that we'd need to add a bunch of lateral mechanisms. And we weren't doing any, we were actually making the building better by taking the heavy brick and precast cladding off. So our approach was to say, look, you're not doing anything to this building that is detrimental. There's no real trigger there. You don't really need to do anything to this building.
And as Jared said, we lightened the load significantly by removing the brick cladding. And you'll see today it's almost looks like a stainless steel building.
Yes.
You had a question right there?
Yeah, you mentioned that you were trying to go for like a higher LEED certification. What kind of changes are you making to the building for that?
That's a good question.
Basically, with the Atrium and Banish architected, their German firm, the standards in Germany for what they consider a comfort in a building and what Americans consider comfort in a building are a little bit different. The Atrium it's just like our atrium out here is a chimney, so to speak, hot air will vent out the top. Any systems, mechanical systems that we put in are much more efficient than what was in before.
And speaking of which, it's a passive mechanical system, so there's actually no AC. So the windows operate automatically. The building automation system is smart enough to know the difference on the temperature on the inside, and then can pull the air, like he said, pull the air through these exhaust fans from outside. And then if it gets too cold, they shut the windows and turn the heat on. And there's radiant floors in the lower level. Again, heat rises, so the whole lower level is a radiant heat system. So you're not pushing any cool air from the system itself. So that's actually a lot of, that's why the building envelope's got to be high performance building envelope. But that's one of the couple points that there's all kinds of green roofs get points for that. How we recycled all the concrete. from the existing building and or well, concrete too, but also all the brick and everything else, all the demolition, all gets recycled. We don't throw anything away. There's a number of other ones I can't even think off the top of my head. But
We're even making benches out of a tree we cut down.
yeah, exactly. Using a tree that was sitting there, was an old sequoia from China that was brought here back in the 80s. Meta sequoia. We cut that, kilned it. Now the artist is using that. That's going to be inside the atrium.
Yeah.
Kind of a cool piece of art.
It's an awesome piece of art. We're working with the artist right now to figure out how to hang it and actually how to keep it from tearing itself apart, because he does, yeah. John Grade, Grade, look him up. He's got some really cool stuff. He's like really well known around the world. He goes to Switzerland all the time. He's a pretty intense guy.
There's a lot of other things, but you know, we can go on and on. There's 81 points we're trying to get, so each point has a feature. Any other questions?